All right, 4.4, number 7. It says you're planning to make an open rectangular box from an 8 by 15 piece of cardboard by cutting congruent squares in the corners and folding up the sides. What are the dimensions of the box of the largest volume you can make this way, and what is its volume? All right, so we're going to chop out corners. We don't know how, we'll just call that X. All of these are X. So my new box, or my box, once I cut it out, will look like this, where we have X high up, because we're folding it right here, folding it right there, folding it there, and folding it up. So we'll have a box. This long is no longer 15. It's 15 minus an X, so this is going to be 15 minus 2X. And this is our new width of our bottom, so it's 8 minus 2X. Alright, so there are the dimensions of our box, and we're trying to find the volume, trying to maximize the volume, so it's length times width times height. So that's our equation. So we just have to find the derivative set equal to 0 and solve. So then we could just distribute. I'm going to just distribute the X to the first one. And I don't know. We could do a product rule, or we could expand this too. So maybe I'll just expand it. So I have a 120 minus, or X, minus 16X squared minus 30X squared plus 4X cubed. So our volume is 4X cubed minus 46X squared plus 120X. Now the derivative should be pretty easy because it's just a polynomial. 12X squared minus 92X plus 120. We could quad this. Just plug it into our calculator and find the quadratic formula. So go to mode. I'm sorry. Go to program. Got a quadratic formula. Coefficients 12, negative 92, and 120. So I got 6, and I got 1 2/3. Alright, so X equals 6, and X equals 1 2/3. 1 2/3, which is 5/3. So the domain of this, if we're going to cut out X inches from each corner like this, this is only 8 across, so the biggest X could be is 4, and even at 4 we'd have 0 left over, so it's got to be less than 4. So there's no way it could be 6. So 6 is not a solution. It's not in our domain of the problem. So 5/3 is where we should cut out. It should be 5/3 from each direction. And we're trying to find the measurement, which are the dimensions. So it'd be 5/3 by 8 minus 2 times 5/3, which is 8 minus 10/3. So 14/3 by, and then plug it in, you get 15 or 35/3. Those are our dimensions. And the volume, if I plug 5/3 into our volume V of 5/3, you get about 90.74 inches cubed. That's our maximum volume.